Okay, we're back with a microphone that's working. Sorry about that. I had to leave because my kids needed something, and so I had to bust out quick. But we're back, and now we got a few hours. Kids are out to gymnastics and dinner with their grandparents. Wife is at a show with her sisters, which means I am home alone and actually have a microphone that works this time. Just so you, I need to, on that note, I have to go get a kid from school. Nice. Have fun, Nightshade, dude. I'm back, baby. Oh, man. I'm going to post my 14-minute video of silence on Twitter soon. Because it's hilarious to me. It's great. Well, good luck with picking up your kid. I'm going to be here hopefully for a few hours, so feel free to come back. I'm just going to be hanging out, doing more Boot.Dev. Absolute cinema. Thank you. I just love that I didn't even pick up on your warning. Like, it completely blanked. Just like, I had no idea what you were saying. Oh, man. Good times. Good times, dude. Just throw a black and white filter and call us a movie interpretation. That's actually very funny. I should do that. Instead of just posting it as is, I should turn it into a silent movie. Make it black and white. That would actually be really funny. I'll go through. If I was really bored, I would go through and put like those, those interstitial that come up in black and white movies with the like words of what people are saying. that would actually be hilarious. Maybe that's what I should do. I should take a little more time and actually go through and put that up as a video. That would be really funny. I feel like AI should be able to do that. No, can't it figure that out for me? But I actually like that. That's a great idea. I'm doing that. I was just gonna post it for fun to make fun of myself, but now I want to post it to make fun of myself and turn it into a black and white movie. That's the new plan. We're doing it. That's very funny. Well, in the meantime, we're gonna go back to exponents and syntax. And Lane told me that they're just called star, which was so boring. I guess I should post that. We're back. We're back. We are so back. Oh man, that was hilarious. It cracked me up. It still cracked me up. I'm still laughing about it. Okay, does this actually work? We are back and actually using a microphone this time. All right. Whoops. I need to learn how to type. Twitch.tv/ Oh, I almost forgot to start recording too. Dumb. Scammer. I know, for real. I was a scammer last time with no audio, Michael. It was great. Who's using the microphone this time? More Boot.Dev. Coming at ya. Okay, let's post it. Excuse me. All right. So we're back to exponent syntax. Assignment. In the social media industry, there's a concept called spread. How much a post spreads due to reshares after... what was I got distracted. After all the original author's followers see it. As it turns out, social media posts spread at an exponential rate. We found that the estimated spread... I personally, as somebody who posts a lot on social media, have never found that my posts spread at an exponential rate. Linear, maybe. Mostly, you know, like a, maybe a sine wave. What's a degrading sine wave? I'm making a math terms, baby. That might be a real one. I don't know. Don't ask me. Okay, we found. Whoops. Audiences, followers. I just want to show it'll wreck if nothing will happen. But oh, type none, didn't define round method. What? Oh, there it is. That's all I cared about. So that's the input. Okay. I just wanted to see it for funsies. Now we are going to build this estimated spread or audience, or let's see, we'll say follower in audiences followers. We need to we're gonna need estimated spread. So we'll set that to 0 equals 0. And then we're going to take the so estimated spread, estimated spread plus equals follower average audience followers. Hold up, we gotta do the average. So what are we need to add them all together first though. So we need to do this. So plus or minus the follower, because that's gonna, so it's not really estimated spread, it's total. I don't know what we're gonna call this. It's really just the followers total. And then, so when that's done, then we'll have the followers total. So then we need to do the average. So I guess we could also do the average would be, I'm gonna do this in like lots of steps and then we'll go back. Average equals the followers total. Except I can't do this each time. So this does need to happen after. So we should return followers total. Right? Why doesn't it like that? It's not defined, so we need to do this. Like I said, we're just gonna do it. It'll probably be terrible. I don't know why I did that. So average equals the followers total divided by the length of audiences followers. Then to do the estimated spread, we need to do, so estimated spread. I guess I actually don't need this one as 0 now that I know what I'm doing a little bit. Estimated spread equals the average times the, oh wait, I'm an idiot. Hold on. In this list of individual follower counts of authors. For example, authors 4 total followers. Complete the get estimated spread function by implementing the formula above. The only input is audiences followers, which is a list of the follower accounts. Average audience followers. I think this is right. Let's just see what happens. Average times, if I make my life easier by doing this, I could do, if I follow his rule, or his num followers equals the length of audiences followers, and then I could get rid of this as a length, and then I don't have to use it again. We can just do num followers. And I could actually probably just put this in a single function of just going estimated spread equals the follower numbers times the num followers. Oh, I'm making this ridiculous. Num followers to the power of 1.2. And actually, I mean, I really just need to return the estimated spread. And do I need to do this return here? I don't think so, right? Let's just see what happens. Okay, I'm gonna try and run it. Hey! I think we did a pretty good job there. Okay. And then, okay, it did say it should just return 0. It did say it should return 0 if there's no... if the list is empty. So let's just run through if this would return 0. It would have the number of followers equals the length of audience's followers, which would be 0. And then for follower and audience followers, if it's 0, does that error out? It doesn't, right? That'd just be 0. It's just because it just wouldn't do it. And then the estimated spread would be, oh, it'd be followers total divided by 0. So that would mess up. Right? So do I need to do... I don't know if I actually have to do this, but... if... length of audience's followers equals 0, then return 0. I don't know. I don't think I actually have to do that. I think that is overkill. But I don't know. I don't know, man. I'm just going to try it. Let's see what happens. Oh my gosh. Yeah! All right. We did it. Now let's just see how I did on the solution compared to this one. Okay, num followers equals like, oh. Okay, the only thing I should have just done this before. Sum plus equals num. I did. Oh yeah. Okay, I did that. Average followers, and then they just. Okay, I could have just done that. That's what I was wondering. So I could have just done, and I should just be able to do this, right? Return. Oops. Just return this. Oops. I forgot that I set it to use. If I just return that, will that work? I wonder if that'll work. I'm going to try that. And then I'm also going to do what they did. I'm going to define this first. Oops. And then, oh my gosh, now I don't even know how to use NeoVim commands. What did I delete? I meant to do num followers equals length of audience followers. And then I don't need this to be such a long thing. You can just do that, return 0. They just did sum. I'm doing followers total. That's fine. Then I wonder if that'll still work. Oh, it does. Okay, cool. I wasn't sure. That still passes everything. Perfect. We did it. That felt pretty good, actually. Maybe I remember a little bit more of this than I thought, huh? Maybe I do, maybe I don't. Who knows? Okay, hold up. I am here, but I need to check something. Uno momento, por favor. Dun, 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 dun. Okay, perfect. That's awesome. I'm glad that that worked. Hold on, I'm checking on this. No. Oh my gosh. I clearly broke something on a different thing. I love that the last comment on here is just scammer. Oh my gosh. Okay. Oh. Shall we continue? You know what I do need? I need a monster. I need a monster. Okay, I'm gonna go get a monster. All the 0 people that I think are in here right now, you have fun. I'll be right back. You can still hear me because I got a microphone. Going to the garage fridge and getting a monster. Oh yeah, this is what you do when you forget to mute yourself. You gotta sing for the crew. All right, do it. We're gonna be up all night, baby. Rocking. Oh, who's messaging me? Oh, cute. All right. Anybody in here? Is it just me? I don't even know. I keep seeing stuff on Twitter with my React Miami. So depressing. Next year is the goal. Should probably learn a little bit more about React first. Bum, 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 bum. Oh, okay. Okay, well, we did that lesson. I feel very happy about that. I didn't think I was gonna get it right off the bat. So, crushing it, man. Well, that was weird. Bum, 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 bum. Okay, here you go. You ready for this sound? Oh, yeah. That's the sound of energy. Oh, needed. Absolutely needed. Oh, yeah. Okay. Exponent quiz. Exponents are really simple once you get the hang of them. 2 to the power of 2 in the expanded form. 2 to the power of 2. 2 times 2 is 4. 4, 8, 9, 27, 16, 64, 256. There you go. Sometimes exponents are also written using the caret symbol. Yes, and just to give you a bit of vocabulary, 5 to the power of 3 is read as 5 to the power of 3. Nailed it. 5 is the base, 3 is the exponent. Thank you. 2 to the power of 10 is what? 2, 10 times. What are we thinking, people? Does anybody know? What is 2 to the power of 10? I mean, I could do the math, but I feel like I should know this off the top of my head. I'm really bad. Is it 100? No. What? What is it? Is it 512? It's 512, right? 512? 512? 512.com? What? Doesn't even make sense. No! Oh, shit. What is it? Is it 1024? Ah, I did 9. What a dummy. Who invited this guy? Okay. Well, that was silly. 10 to the power of 3 is 10 times 10, which is 100, times 10, which is 1,000. Listen, I might know how to do things. That is different than being able to get the right answer. So, yeah. All right, what's next? Exponents grow. Haven't you heard? Exponential growth, baby. Okay. Exponents grow. Exponents grow very large very quickly. Let's take a look at an example of them doing that in code. All right, hold up. We're going to pause this bad boy. Pause the music. Let's listen to Lane, everybody.
Say a company earns $100 in their first year of business, and then in the second year they earn $200, then
Whoa.
$400, then $800, then $1,600, doubling every year. This growth pattern is an example of a geometric sequence. Each number in the sequence is calculated by multiplying the previous number by some fixed number, which we usually refer to as R. And in this case, of course, that fixed multiplier is 2. Let's take a look at another example. Let's say that we start with the number 3, first number in our sequence, and that R is 4. Well, the next number is 3 multiplied by 4, which is 12. Then we multiply by 4 again, getting 48. Then multiply by 4 again to get 192. And then again to get 768. Now, of course, there's an actual formula for this math that we're doing. A sub n, which just means the number that we are trying to calculate, the spot in the sequence that we care about, is equal to a sub 1 multiplied by r raised to the n minus 1. A sub 1 just refers to the first item in the sequence. R is that.
Math, this is why people don't like you. All right? You start off all simple. You lure us in with your simplicity. And then you immediately start throwing this ridiculous stuff at me. Like, come on, math. Why are you trying to do this to me? Pretty rough, man. Okay, so let's listen to Lane explain it. And maybe we can learn something together.
That common ratio, the multiplier. And again, n is just the index of the number that we're trying to find in the sequence. For example, let's say we're trying to find the 7th number in a sequence where the starting number is 100 and the common ratio or multiplier, r, is 3. We can just plug that into our formula. A sub 7, the 7th number in the sequence, is equal to 100 times 3 raised to the 7 minus 1, which of course is just 6. And because 3 to the 6th equals 729, 100 times 729 is just 72,900. So that's our 7th number.
All right, Lane. All right, buddy. You got me buying what you're selling here. All right, let's do this assignment. While the influencers who use our platform are really great at taking selfies, most aren't super great at math. We need to write a tool that predicts an influencer's growth, follower growth over time. Complete the get follower prediction function. It takes a follower count integer, an influencer type string, and a number of months integer and returns an integer. Calculate the number of followers an influencer will have after a given number of months according to the influencer type. Fitness follower account quadruples each month. Cosmetic follower account triples each month. Other follower account doubles each month. For example, if a fitness influencer starts with 10 followers, then after 1 month, they would have 40 followers. After 2 months, they would have 160 followers, and so on. This kind of sequence, where each term is found by multiplying the previous term by a constant, is called a geometric sequence or geometric progression. Use the following version of the geometric progression formula in which A1 is the initial number of followers, R is the multiplication constant, and N is the number of months. Okay. So we get a follower count, an influencer type, and a number of months, and we are just trying to implement that function. I feel like this is like a one-liner, isn't it? Because it's really just a return follower count is okay. Influencer type. Oh no, because influencer type we're gonna need to convert into something. So, do we have to do ifs? Do we have to do if statements for the influencer type? Is that the only way to convert it properly? Yes, it is. Right? Well, hold on. So we're just gonna do this. If influencer type equals fitness. Well, we should probably do it this way, right? If influencer type. Oh no, that doesn't work. We're gonna have to do else. Okay, if influencer type equals fitness, then we need the R. R equals 4. Else if influencer type equals cosmetic, then R equals 3. Else R equals 2. Okay, and then let's just see if this is working. Can I just print R? Yay! There we go. It's working. Good job. All right. So now we have our R. So now I think we don't need anything else. So A1 is the initial number of followers. Okay, so that's fine. That is the follower count. R we just got, and N is the number of months. Yeah, so now we can just do return. Return follower count times R to the power of number months. Is that right? Is that all we need? Oh, yeah. That is what we're doing. There has to be a better way, though, to set the R, right? It can't just be if statements. It's always if statements. If statements and for loops. Well, let's see. We did it. And is it the right solution? Oh, smart. Yeah, that's smarter. That's much smarter. That's faster. Is it? Well, actually, I don't know if it's actually faster, but it does look better. It does seem like more typing, though. I think I'm using less characters in my solution. Dang it. Dang it. Dang it. Dang it. Dang it. That's still good. I like my solution. I'm pretty happy with it. It's good enough. All right. Sweet, man. So let's keep going. Hold on. Monster break. Well, I'm going to pound that. I should probably drink some water. Ah, shit. Hold up. Bum, 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 bum. Oh. Bummer. Bummer. Okay, wait. I'm gonna do. Let me just share this. Nightshade had a great idea. So when I was doing my video earlier, I forgot to turn on my mic. So now Nightshade was like, "You should put a black and white filter on it," and I think I'm going to. I think it's hilarious. So I'm going to do that. Can I actually just show you me doing that? I probably can. What if I switch to this view and then I turn on, not Steam, not Nintendo. Oh, I guess I don't have an actual, oh, no, not Pico 8 coding. We're not doing that. That's a big face. Nobody wants to see that big face. Woo. Here, we just need a new application. Let's do this. We need to do a window capture, and we're going to do DaVinci, and we're going to add it, and then we're going to capture DaVinci, resolve, and that's it. Is that working? Why are you so big, DaVinci Resolve box? And then we can do this. Yeah, that's all perfect. But why is it black? I'll need to change something in the settings. I know that there's usually like a weird, is it capture method? Yeah, if you do this or this. There we go. Boom. Okay, so here's the video. Let's add a black and white filter. And I'm really terrible at DaVinci Resolve, and I don't actually use it a lot. But because I used to use Premiere. I used Premiere for years. And then I got so fucking sick and tired of paying Adobe that I was just like, screw it. I'm going to go learn DaVinci. So I'm working on it. It's got to just be a filter of some sort. Oh, yeah, there we go. FX color, color compressor, chromatic. Film grain. Oh, yeah, we should definitely add some film grain. Film grain, obviously. Oh, I've reached a limitation within DaVinci Resolve. Unlock the complete set of amazing. I gotta buy it. I should buy it. I do like DaVinci Resolve. I should just buy it from them because it is good. And I probably will. But not today. Not today. DaVinci Resolve. Not today. Today, we see if we can figure out how to turn off that filter that I just added that I don't know how to do. Because, like I said, I don't use this. How do you turn off? Does it work anyways? Even though it's like, if I just press play, will that filter work anyways? No, it just doesn't do anything. What the heck is happening in my life right now? Nobody knows. Okay. How do I just get rid of this effect? Can I even do it? And why is the spacebar not working? What is happening? Encoding overloaded. Consider turning down video settings or using faster encoding preset. Wait, is that on? Is that on OBS? Ah, OBS, are you struggling? Oh, is that why? Is it because I have these two things open and my computer can't handle it? Is that what's happening? That is what's happening. It doesn't know how to handle DaVinci and... All right, I'm closing it. It can't handle those two things at the same time. I need better computers. I could do it on my other computer. That's actually the smart way to do it. Here, wait a second. I could actually set this up. Hold on. First, I just have to get the video. Did I share it already? No, of course not. Oh, Johnny boy. Johnny. Johnny Whoop, as they call me. Johnny Whoop. I am still impressed, though. I haven't done any, like, frame drops. Way to go, computer. You little laptop that CAD. CAD? I've lost it. You know what is a better way to stream? Is to just do the things that you say you're going to do. Oh, did my camera just jump out? Man, I need a new desktop computer so that I can plug all these USB things into a computer instead of a flipping, whatchamacallit, a USB hub. Because I know that that's a part of why this messes up so much. Because it can't hang. With all, that USB hub is pumping a lot of stuff through it, and it just struggles. Okay, hold on. We're going to do this, though. We're going to set this up. I was trying to do this the other day. I should be able to do a computer and then a blah, blah, blah. And I'm sure people seeing the "we'll be back" is very confusing. Because I'm not even going to be back. I'm still here. Okay, let's see if I can get this video on my other computer. And if I can, then I can transfer the... Okay, hold up. Hold up. Is this on? Did I get it? No, it's still uploading. I'm uploading 8 gigabytes. Oh no, I'm starting to drop frames. It's probably because I'm uploading 8 gigabytes. Darn it. I've lost all of my bandwidth. No. Stop. Don't do it. No, that is definitely it though. As soon as I open up my server, oh yeah. Oh, I should shut it down. All right. All right. All right, you punk. Come on. All right, next. You gotta stop. You're done. It's not gonna happen right now. Watch, ready? Get rid of that, and immediately it's gonna come back. Yeah. So it can't handle doing those two things. Transferring an 8 gigabyte video over the network while also streaming is apparently too much for the computer. So that means we'll just have to do our video editing later, because I can't do it on this computer because the encoder can't handle it, and I can't do it on my other computer because I don't have the video yet. So there you go. What are you gonna do? All right, let's go back to what I said I was gonna do the whole time. Boot.Dev, yeah. I need music. What is happening? Baby, let your light shine through. Bum, 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 bum. No, I don't want that song. Where was I? We're just gonna press forward a bunch of times and see what happens. Oh, I can't believe I dropped all those frames. What a fool. It goes. Oh. All right, tunage on. Oh, I still can't believe. Ow. Oh. Yo, what's up, Guga? How you doing, man? My day's good. How's your day going? I've just been doing some Boot.Dev and rocking out a little bit. I was streaming a little earlier, and then I had to go do some dad duty, and so I had to bail really fast. But now I'm back. So we're currently doing data structures and algorithms course, which is cool, because we've been way off the Boot.Dev for way too long, getting a little bit too much of the AI psychosis happening, you know, just spending way too much time with Claude and ChatGPT. So now we're back into it. So we just finished this lesson. Let's go to the next one. All right, non-linear growth. Exponents are important to understand when it comes to the execution speed of an algorithm. If the number of operations grows... Oh, shoot. Hold on. I don't have my keyboard set up. 1 second. If the number of operations grows quickly as the amount of input data increases, the algorithm will become slower and slower. Well, hope you're alive. We'll get more views. Good luck. Thanks, man. You know, the fun part about it is I just really enjoy doing this. And when people show up, it's great. And I like when they talk, and it's a lot of fun. But if they don't, I just get to talk to myself, which I would do anyways. So it works out pretty well. But thanks for stopping by, and hopefully you'll swing by again. We do lots of random things. Some coding, some video gaming, some a lot of me getting distracted and just talking about random things. It's perfect. All right, so linear versus quadratic. Look at that quadratic difference. The doubling formula, 2 times x, results in linear or straight growth. The quadratic formula, x to the power of 2, keeps growing faster and faster. I will subscribe. Oh, thanks. Oh, you subscribed. I didn't know. Thanks, man. I appreciate that. That's awesome. We're having lots of fun. I appreciate the sub. So, what does this have to do with... Oh, I realize I'm not showing anybody what I'm doing. Unless you're on the mobile. If you're on vertical view, you can see what I'm doing. There we go. Now everybody can see what I'm doing. This is much better. In case you were wondering, I am very good at this. When it comes to streaming, I am top quality. Top tier, you know? Just fantastic. Okay, what does this have to do with code? Generally, we try to avoid writing code that causes the usage of a resource to grow quadratically with an exponent. I did not read that parentheses very well. To grow quadratically with an exponent. There we go. Sometimes, oh God, sometimes that's a lot of computations, CPU utilization, slowness. Sometimes that's a lot of memory usage, RAM utilization. Sometimes that's a large storage requirement, disk space. A notable exception is in cryptography and security. We want to force attackers to waste resources trying to get at our information. There you go. I guess Bitwarden should have done some more of that, eh? The result of which operation grows fastest? Multiplication, exponentiation, division, addition. That would be exponentiation. Boom, nailed it. Non-linear growth. Oh, wait, we already read that. Yes, we already read that. Just a second question. Okay. How much larger is 2 to the power of 64 than 2 to the power of 32? 2 to the power of 64 is 32 times larger than 2 to the power of 32. 2 to the power of 64 is 2 to the power of 32 times larger than 2 to the power of 32. 2 to the power of 64 is 2 to the power of 16 times larger than 2 to the power of 32. 2 to the power of 64 is 2 times larger than 2 to the power of 32. Okay. So, I believe... Is it 2? 2 to the power of 64 is 2... Let's do a shorter example. If it was 2 to the power of 2, that would be 4. And then versus like 2 to the power of 10, which is 512. So the only way to get to that 512 from 2 to the power of 2 would... It'd be 2 to the power of... Oh. I think it's 2 to the power of 64 is 2 to the power of 32 times larger than 2 to the power of 32. I think it's 2. And since there's nobody here to stop me, I'm clicking it. Boom! Heck yes, friends. That's what I'm talking about. Man. Maybe I'm a little bit better at this stuff than I thought. I'm going to let my britches get real big, and then it's going to come crashing down on me real soon. All right, a logarithm is the inverse of an exponent. 2 to the power of 4 equals 16. Log 2 to the 16th equals 4. Oh yeah, log base 2 of 16. I forgot how to read logarithms. It's been a long time. So log base 2 of 16 means the number of times 2 must be multiplied by itself to equal 16. So log base 2 of 16 can be written as log 2 16. Okay. So that would mean... So it's just the opposite, like they said. So log base 2 of 8 is 3. Because if you were doing that as an exponent, that would be 2 to the power of 3 would be 8. Got it. I think that makes sense. All right, let's watch the old video. Hold up. We're going to pause the tunage. And we're going to listen to Lane explain logarithms.
A logarithm is the inverse operation of exponentiation, basically a backwards exponent. So we know that 2 to the third power, 2 times 2 times 2, is 8. And 2 to the fourth power, or 2 with a 4 exponent, is 2 times 2 times 2 times 2, which is 16. A logarithm is when the thing that we're calculating isn't the result of exponentiation, it's the exponent itself. In these examples, the 3 and the 4. For example, log base 2 of 8 is 3. Just like 2 raised to the 3 is 8.
Oh, it's funny that you picked that example. That was the same one I picked.
And log base 2 of 32 is 5. Now, in mathematical notation, log base 2, the base is typically written in subscript, of 16 equals 4. That's how we'd read it in English. And what log base 2 of 16 really means is, what I recommend you kind of think of it in your head as, is what's the power that I need to raise 2 to get the result of 16? And of course, in this case, the answer is 4. Now, the base doesn't have to be 2. In programming, it's really common for the base to be 2 because we work in binary. But we could also take log base 10 of 1000. And what do you think that is? Remember, the question is, what's the power that I need to raise 10 to get a result?
Oh, I should have done this. This would have been a lot better. What is it? Oh, damn it. I wasn't fast enough. But that's what I should have done. I should have paused and let everyone have a guess. I say everyone like I'm flooded with people watching this right now, and I know I'm just yapping to myself, but still, that's that's still what I should have done. I got to get in those habits, you know? Got to improve the stream. All right. Anyways.
3, because 10 to the third is 1000. Let's take a look at a bunch more examples. Log base 2 of 2 is 1. Log base 2 of 4 is 2. Log base 2 of 8 is 3. Log base 2 of 16 is 4. Log base 2 of 32 is 5. You get the idea. Log base 10 of 10 is 1. Log base 10 of 100 is 2. Log base 10 of 1000 is 3. And log base 10 of 10,000 is 4. So it's important to understand that exponents grow very quickly. 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 20th is 1,048,576. On the other hand, logarithms grow very slowly. Log base 2 of 2 is 1, log base 2 of 4 is 2, log base 2 of 8 is 3, log base 2 of 1,048,576 is just 20. And even more crazy, I'm gonna have to read this one off. Log base 2 of 1,099,511,627,576
It's gonna be like what, 21 or something?
Is 40.
40.
Now, because logarithms grow so slowly, they're really useful when it comes to coding and computer science. When we write a program that gets slower in exponential time, that means it's going to get really slow as its input size grows. But if our program only gets slower at a logarithmic rate as its input size grows, it's going to be a really fast program.
That makes sense. I mean, obviously it makes sense, but like, I've actually never really thought about it in terms of like why you want logarithmic speed on your programs. But obviously that's why, because you want it to be able to handle more data without becoming super slow. I feel like this is the thing that will be interesting with LLM and like vibe coding stuff. I'm sure, I do believe one day it won't matter. I actually do. I think that's way further off than anyone that's trying to sell you a subscription to their LLM service is talking about. But I don't know. Every time I've like vibe coded something, if I don't pay super close attention to it, it's always adding so much extra garbage to it. And I feel like it doesn't focus on things like building programs logarithmically or focused on having code generation and how it handles the functions logarithmically. I think it just builds it. And I think you're going to end up seeing a bunch of garbage continue for a long time. Like I said, I think one day it won't matter. I do actually believe that there will come a time where they'll be smart enough to just handle it. I mean, it doesn't seem like that weird of a stance anymore. And I will fully admit I didn't think that for a long time because it seemed so terrible. But it is interesting that it does seem to be getting, it is getting better a lot faster. So we'll see. But I still think learning it is valuable. Okay. Python syntax. There isn't a language level operator to calculate a logarithm, but we can import the math library and use the math.log function. Oh, Python and imports. Assignment. Let's create an influencer score. It will be a small number, like less than 100, that will give influencers a metric for comparing their social media success against their peers. Complete the get influencer score function. An influencer score is their average engagement percentage multiplied by log base 2 of their follower count. Yo, Lava, what's up, man? How are you? You just came in as we're doing some logarithmic learning. Logarithm is a good way to show how terrible I am at learning. That's how fast I learn. I don't learn exponentially. I learn logarithmically. You just did leg day. Nice. I went out and did a bunch of gardening stuff, so I feel pretty good. Got a bunch of working out in. I do that unk. Stubby said, you settle down, Alavo. I do that dad lifestyle workouts, lifting kids and pushing lawnmowers. That's my workout. Okay. Should we try this math.log thing out? Figure it out. Okay, we need to, let's see if we can do this. So, influencer score is their average engagement percentage multiplied by log base 2 of their follower count. Oh, okay. So this should be super straightforward. That's self-derogatory shit. I'm never going to be alpha, bro. It's not how I roll. I love self-derogatory. It's super Canadian to be self-derogatory. I swear to God. I think that's like just a huge part of our comedy up here. I don't know anybody that's from here who doesn't do that. It's all about making fun of yourself. Yeah, I'm fine with being a beta. Betas rock, Betas just kick it all day, every day. It's how we go, man. I'm not gonna do any like. Would you want me to do some like clavicular, like should I start punching my face and get into my looks maxing arc or what? Dude, I'm already gorgeous. I don't need to look back. Look at this guy. Oh, looks maxed already. Turned up to 11, bro. I don't I don't need to pay attention to that other stuff. Come on now. That's how we roll. All right, let's write this. This should be super straightforward. It should literally just be return math.log of the two numbers, which is, yeah, I got a shower. See ya. Peace out, dude. Good luck on leg day. Try not to fall over now that your legs are all weak. I'm gonna try and be on for another hour-ish. So if you decide to come back, dude, I'm here. We're just doing that Boot.Dev, baby. All right, let's see. We just need to do multiply by log base 2 of their follower count. So their follower count is oh, hold on. Sorry. Doing that booty. That's right, baby. So it's their average engagement percentage times math.log of number of followers times 2, right? I think that's it. Let's see. Is that right? Oh, I spelled followers wrong. That doesn't help. Let's try that, baby. Ooh! Anthropic Mythos. You got nothing on this guy. Come on, baby. Dang. That was good. I feel good about that one. Heck yeah, dude. I love getting these. All right. Hold up. Hey, yeah. What am I looking at? I don't even know. I'm looking at a different screen that you guys can't see. Deal with it. No, I'm just trying to find something. It doesn't matter. Doesn't matter. I would also just like to say, I don't know how it happened, but somehow I'm over 120 followers on YouTube, which is awesome. So thank you to people who started following me. And I'm over 70 on Twitch, which is great. Was not planning to see that happen anytime soon. So that's great. This is sweet. All right, we're going to get back into some more logarithms. But I can't believe actually, I shouldn't be too cocky. I haven't actually run the submit yet. Come on, baby. Yeah. Oh, yeah. That's a dangerous move. All right, sweet, man. Looking good, feeling good. Let's go to the next one. Logarithm quiz. Exponents grow very quickly and logarithms grow very slowly. A logarithm is the inverse of an exponent. So we got linear, we got log. Generally speaking, it's nice when we can write code that uses log n time to run, where n is the amount of data to process. For example, let's say we have a list of 1 million users and we want to write an algorithm that finds the user with the most followers. If it takes 1 millisecond to check one user, let's just pretend, a linear algorithm would take 1 million milliseconds, or about 16 minutes and 40 seconds. A quadratic algorithm exponent would take 1 trillion? Million, billion, trillion. 1 trillion milliseconds, or about 31.7 years. However, a logarithmic algorithm would only take 20 milliseconds. Here's a table to illustrate the difference. Here, I'm going to do this. Bloop. Yeah, that is wild. I mean, it makes sense, but it's still wild. I'm going to write all of my code quadratically going forward. So it really seems like the goal is to write code logarithmically so that your bank account grows quadratically. Oh, it's math. We're mathing in here. Heck yeah. Okay, so what's the quiz? Oh, log base 3 of 9 is 3 times 3, which is 9, which is 2, right? Wait, no, 3, 3. Why am I so bad at math? 3 to the power of 0 is 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9. There. I should have just gone with my gut. I was pretty certain, and then I panicked. Classic panic. Okay. We got it. Next quiz. Okay, log base 5 of 5 is greater than... I mean, if it's going to be false regardless. Because log base 5 to 5 is 1. And that's 5 to the power of 5, which is... What is 5 to the power of 5? I don't want to calculate that in my head. I'm not smart enough. 5 to the power of 5. I mean, it would be 5 times 5 is 25. 25. It's a lot. So long story short, false. Which we knew right off the bat because we know that logarithmic is much slower growth and linear is, or quadratic is much higher. So We knew the answer just by looking at it. What is 5 to the power of 5, though? 5 times 1, 2, 3, 4, 5. 15,625? Is that right? I don't know. It's a lot. Let's see what it says when we press explain. What's boot say? Oh, 3,125. I just did the thing wrong. Answer is false. Yeah, Boots, we got it. Thank you, though. Okay. The result of which operation grows slowest? Logarithm. Boom. Sharpshooter Sharpshooter chest on it. All right. Heck yeah, dude. Living the dream here. Just living the dream. Bum bum ba da na na bum 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 ba da 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 bum 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 na na bum 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 ba da da da. Whoa, YouTube sent me 72 people viewing this at some point. That's wild. I should pay more attention to YouTube. Sorry, YouTube. That's sweet, man. Thanks, YouTube. Okay, next tube. We're going to look at... Oh, hold on. Okay, we are going to do the next lesson. We're almost done with the math that you'll need for this course. Okay, is this the last lesson in math? Oh, not even close. We got to do factorials, factorial quiz, exponential decay, logarithms. Okay, we're going to finish 11 through 16, see what time it is, and then I might play video games for a little bit. May Tessa come home? Oh, shoot. Of course. When did she send that? Yes, of course. Okay, hold on. I got to run for 2 seconds. I'm here, but I'll be right back. Hold up. Okay. Hey, I'm back. Sorry. Kids, man. Kids. You know? You gotta you gotta go take care of them when they need stuff. It's just the way it goes. But I'm here. Oh, I didn't. Did this not change back? Oh no, it's fine. Okay, we're good. All right. Whew. Back to Boot.Dev. I'm sorry for leaving right when you came in. I am sorry. It was bad timing. I just had to run and go help out my daughter who's hanging out with her grandparents, but she needed something, you know? All right. We're going to do, this is the plan to finish off the day. We're going to do factorials. We're going to try and get through all of these last quizzes or these last lessons. Then we're going to finish the day with some tape to tape. Why not? I love playing tape to tape. We haven't played it in a while. All right, so we are back. We are back. Sorry again for having to leave. Let's see what we can finish up. Booyah. All right. We're almost done with the math that you'll need for this course. Just one last thing, factorials. Let's listen to the video.
What is this equal to? If you're a programmer and you let your eyes deceive you, you might think 5 exclamation point means not 5. But no, it's actually a math thing. It's a factorial. A factorial is the product, meaning the multiplication result, of all the positive integers less than or equal to the given number. So, for example, 1 factorial is just 1. 2 factorial is the same as 2 times 1, which is just 2. 3 factorial is the same as 3 times 2 times 1, which is 6. 4 factorial is the same as 4 times 3 times 2 times 1, which is 24. And 5 factorial is the same as 24 times 5, right? Think about it. We already did all the other ones. So 5 factorial is 120. Now, there's also a special case. 0 factorial is equal to 1. It makes a bunch of math work out nicely, so that's just how it works. Now, again, when it comes to programming in Python, the exclamation mark is not a factorial operator. You can't write 5 exclamation point in code and expect to get a function that calculates factorial. You need to write it manually. So let's go ahead and write one. We can define a new function called factorial that takes the number as input. We'll just call it n. Then we keep track of a product. We'll start at 1 because remember, both 0 and 1 factorial are 1, so that makes sense. And then for I in range 2 to n plus 1. Or in other words, for every number from 2 up to n, because n plus 1 is exclusive, we'll multiply the product by that number, and then when we're done, we return the product. Now, let's run our function and see how insanely fast factorials grow as n gets bigger. The factorial of 5 is 120. Factorial of 6 is 720. Remember, it's just 120 times 6 now. Factorial of 7, 5,040. Factorial of 10, 3,628,800. And factorial of 20 is, I can't read that. There's 18 digits after the 2. So they get really big really fast. They actually grow even faster than exponentiation. For example, 20 factorial is astronomically larger than 2 to the 20th because the base keeps increasing with every multiplication.
Makes sense. All right, Lane. Thank you, sir. Factorials. Making sense. Making sense. Loving it. All right. The factorial of a positive integer n, written n exclamation point, which is n factorial, is the product of all positive integers less than and equal to n. 5 factorial equals 5 times 4 times 3 times 2 times 1 equals 120. Is factorials the thing that you use in that riddle that's like, if there's 10 people in a room and you shake everybody's hand, how many hands do you shake or some weird thing? I can't remember. I'm butchering I feel like there's like some weird random riddle that you need to use factorials for. I'm just turning my music back on. Hold up. Because we want tunage in this place. The results of factorial grow even faster than exponentiation. N factorial grows faster than 2 to the power of n. And you can see in that handy dandy chart what is being discussed here. Assignment. Let's do it. Influencers need to be able to schedule posts to be published in the future. we found that the order in which the posts are published drastically affects their performance. Complete the num possible orders function. It takes the number of posts an influencer has in their backlog as input and returns the total number of possible orders in which we can publish the posts. Let me guess, we're gonna have to do a factorial. So I think to do factorials, you gotta do a for loop, right? So for num in num posts, then you do, so you're gonna have the num times, no, wait, you can't do that because that you need the total. Yeah, okay, so wait, so you actually need to do for num in the length of num posts, right? Because that'll give you the number. Oh wait, is it not in? What is this not like? Object type int is not in. Oh yeah, right. Oh yeah, he just showed me this. Why wasn't I paying more attention? You have to do, what did he just do? It was like a range, right? It was, I should just look it up. It was, yeah, there. That's what I'm doing. Why did I try to make this so much more complicated? So it's for I in range, and then we need to do 2n plus 1 in range of num posts, and then am I doing this wrong? Shoot. Wait, this is gonna be wrong, right? Well, we're just gonna do it anyways. Let's see what happens. And then we're gonna do product times equals I, and then we will return product, which means we also need to set product to 1. Is that right? No. Flip. What did I mess up? For I in range. Yeah, it's this part. It's not the number of posts. That's the part that I'm messing up. Because I need to do because that just gives 5 or 2. Oh, why did that one pass? Number of posts is 2. Expected 2. Actual 2. 3. Expected 6. I'm not doing this properly. Range 0 num post? Is that what it is? Do I need to do the 0? But I think I do need the num post plus 1, don't I? No. Oh, it wasn't that. That didn't work. Nightshade dude. What is it? Is it num post, not plus 1? Is that it? Is it this? No. It wasn't that. What am I missing? I'm missing something so stupid here. Should we look at the tip? Let's look at the tip. What is Python's range? You have to do, like, in the range, because it ends, it does need plus 1 because it ends at the one before the end. So like if you say 10, it'll do it 9 times in Python. So if you want it to do all 10, you have to actually do the plus 1. But what am I missing here? That means the total number of possibilities is the 52 options multiplied by 51 options multiplied then by, yeah. I didn't count the zeros, but I think this is correct. Hold on, factorials are that tip is useless. So the range, like I'm pretty sure I'm close here. What does num post then? What's the assignment? Non-inclusive. Got it. Try 1 num plus 1. All right. Let's do it. Ah, you're a genius, Nightshade dude. Genius. That's all it was. Now I don't remember how range works though in Python. I want to look it up. How does range work in Python? Okay, yeah. So it's the start and the stop. The starting number of the sequence defaults to 0. Oh, and it has to be 1, right? Because if it's 0, then the first 0 is 0, and then the product is 0, and then so every time it's just 0, right? That's why. So you have to start at 1, which actually, do you need to define this? You do, right? You do have to have that still, right? Yeah, okay. Just making sure. I just wanted to make sure. But okay, that makes sense. I did forget how range worked, and that was why I couldn't remember what to start it with. But that makes sense. We got it. We got there. Did I do this? We passed the lesson! Yeah, lurk, man. Lurk away. I'm going to try and finish, just so that you're aware of what's happening, I'm going to try and finish these 12, 13, 14, 15, 16. And then depending on the time, I might just do a little gaming or something just to kill a little bit more time. But we'll see. We'll see. All right. Let's go to the next one. Oh, wait. I forgot to look at the solution. I do like to see what the solution is. What did it do? Oh, we did it perfectly. I just have an extra space in here for some reason. Beauty. Okay. Next. Factorial quiz. Again, the factorial of a positive integer n, written n factorial, is the product of all positive integers less than and equal to n. Let's visualize how big these things get. Oh yeah, look at that. Even bigger than a quadratic. Wild. Yeah, that is intense. Dang. How much larger is 564 factorial than 563 factorial? It's going to be... Ooh, is it 564 times larger? No, wait. 564 times larger or 563 times larger? I think it's this one. Yes! Champion. I love getting these things right. Oh, I didn't know I could do that. Control plus period to go forward and back. Oh, snap. Oh, yeah. Woo-hoo-hoo-hoo. We're keyboarding it. I like this. Okay. Which grows the fastest as n increases? It's n factorial. 2. Booyah. Oh, Lane, when did you make Boot.Dev fully just using a keyboard? Like, I can do everything. This is incredible. I'm still going to use it for this, but... Okay, exponential decay in physics. Is that the computer stuttering or me? In physics, exponential decay is a process where a quantity decreases over time at a rate proportional to its current value. We found that locked-in influencers tend to lose followers similarly. This means that the more followers you have, the faster you lose them. Assignment. Oh, this is like a big assignment. Eek. Is this the last thing? No, not even close. Okay. Complete the decayed followers function. It calculates the final value of a quantity after a certain time has passed, given its initial value and a rate of decay. I wish I could explain to everyone that while my brain is reading that, I am not understanding any of it. I don't know why, but it's like when I introduce myself and ask for somebody's name, and then my brain decides, hey man, you don't want to listen to this person's name. So you should just start thinking about other things. And it's infuriating. Infuriating. Because, like, I'm reading that, and I know that I'm reading words, but I have no idea what I'm actually saying while I'm reading it. It calculates the final value, okay, so the ending value of a quantity, so of a number of things, after a certain time has passed, given its initial value, which is the number of things, and a rate of decay. So in this follower total, let's see if I can put this into my own words. That's the whole point, is like it's calculating the total number of followers after a certain amount of time has passed, given the amount of followers the person started with and some rate of decay, which we don't know yet. So the retention rate, so let's read the formula. Remaining total equals quantity times retention rate to the power of time. Okay. The retention rate is the opposite of fraction lost daily. If an influencer lost 0.2 or 20% of their followers each day, then the retention rate would be 0.8 or 80%. Example. With these parameters, initial followers equals 100, fraction loss daily equals 0.5 or 50%, then we would expect these results. After 0 days, 100 followers. Makes sense. After 1 day, it's half, 50 followers. 2 days, half, 25 followers. 3 days, half, 12.5. Rounded down. Good to know. This isn't solving problems. Give me sexual tension. I need this Booty.Dev thing. Dude, go pay for Boot.Dev. It's worth it. It's not cheap, but it is worth it. And also, Lane does do lots of like 50% off deals. Not tons, but every once in a while. If you can jump on it and do the year when they have it, that's what I've always done. Sorry, Lane. But it's way better. I know, it is expensive, but they're a lot of fun. And you can do a lot for free for whatever that's worth. You can actually do quite a lot of this for free. So, yeah. This, like, I would go use what Boot.Dev offers for free. That's what started me on it. And then I really liked it so much that I was like, I'm going to pay for it. And then I got to meet, and then, like, I haven't met him in person, but then I talked to Lane a little bit, and I was like, oh, yeah, I really like what you're doing. So I'll try and support you if I can. But yeah, it's not cheap. I can fully admit that. Okay, I'm going to try and do this and see if I can figure it out. So we need to do, basically we're just coming up with that formula. So we have initial followers, we have the fraction loss daily, and we have the number of days. So we have the quantity, we have the retention rate, and we have the time. So we should actually just be able to do this in a single line. So we should just be able to return the initial followers times the fraction loss daily to the power of days. I think that's right. Oh, shit. Nope, not even close. I passed one. Which one did I pass? Oh, the one where... Oh, because I didn't do the for loop, so I'm an idiot. That's all. Oh, I'm such an idiot. Because I have to do for I in... Wait, do I have to do this? Oh, because it worked on the one. Because, yeah, I have to do it as a loop, right? Do I? I think so. Is that why this messed up? So what if I do this? In the range of 1 to the days plus 1. And then we do initial followers times equals what did I just do? Hold on, I'm just going back to this. I just want to look. This equals I. So times equals I? Is that all I have to do? No, but that doesn't have my fraction loss daily. Times... Do I have to do this? Times fraction loss daily to the power of time? Is that right? Nope. Oh, what did I do? Oh, I need a thing. Oh, and then also I need to return if I want an answer. Oh, oops. No, I need... Oh, I'm an idiot. That's not going to work because that's not going to give me my remaining total. Oh, I'm so dumb. Do I need to do this? Remaining total equals... minus equals? I'm just making stuff up now. I don't know what I'm doing. I got confused. Ah, I need this to set remaining total, though, don't I? Yeah. I don't think this is gonna work. I just went a little nuts. I'm gonna have to rethink this. But until then, I'm just gonna do this. Remaining total equals initial followers. This is such a bad idea. Oh, hey, that was actually... I'm close. Why am I close? What am I... I'm just doing one thing wrong. Wait, is it just because I should actually be doing this? Nope. What have I done to myself? Shoot. We're just gonna do this. What did I do? Initial followers. I've lost the plot, everyone. I've lost the plot. Why is this so close, but just not quite right? What am I messing up? Oh, no, that wasn't it. This is how I do everything. It's the most annoying way possible. Okay, we're starting over. We're starting over because I'm clearly doing something. I'm off on something in my thinking. I'm gonna print this. I want to see what it comes out with each time. Every time it runs, what am I getting here? Oh. So let's just see. If this was working properly, 200, 40% of 200 is what? 10% is 20, 40, 60, 80. So that would be 120, which is right. But then I think it's just missing one. Right? Do I need to do this range for this? Oh, shit. Nope. The 0 is definitely wrong. Which makes sense. Do I need to be doing this? No. Shit. Okay, we're gonna get there. We're gonna get there. What happens if I do this? Now I'm just messing around. We're gonna figure this out. Okay. Hold up. What happens if we do this? Anything? Is this something? No? Shit. Oh, I'm so bad at this. Fuck. I'm close. I know I'm close. I was very close before, and that just means I'm messing something stupid up because I don't know what I'm actually doing. Okay. Oh, wait. What if we do... No, that does make sense, but I don't want to... Okay. Let's try... We're just going to do... We're going to get rid of some things, and we're going to start over. Okay. Oh! Is it minus? No, plus one's right. Right? Hold on, I'm going back. Plus one. Okay. So, we need to do this. That makes sense. But then, what we need to do... After 0 days... What happens if we did do 0? I'm just curious now. And if I print I, what does that do? Will that give me all the days? 0, 1. Okay, that makes sense. And then we're just doing initial followers minus equals. I'm just curious. What happens if I do this? Oh, I want to print this. We're just doing some testing. We're doing... Oh, wait, I can't do that. We're doing some testing here. Okay? Doing some testing. This is how my brain works. Print initial followers. Okay. Okay, so that's doing the right thing. So initial followers minus equals... Does it need to... If I just do this... Now what happens? Okay, so that is not... What happens if I do this? Oh! 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 Hold up. Hold up. Return. Wait. Damn it. What? 8, 12. No, okay. Okay, what happens if I do this? Then what do I get? Okay, so that's wrong. We know that. What if we just do this? I just want to see what this does. Okay. That is wrong. That's fine. But what if we do remaining followers? Followers. And what happens if I do that? Huh? What happens if we do that? No. Darn it. I'm missing something simple. I know I am. And I just don't know how to fix it because I can't figure it out. Okay. We're very close. Oh, wait. Does that matter? Or should we do 0 this time? I think we want 0, right? 80, 32. Oh. What happens if I do that? Oh, no, that doesn't work because I would have to set remaining followers. Okay. What am I missing? I don't ask Boots yet. I'm not ready to ask Boots. I'm so close. I can taste it. I know we're close here. Okay. Initial followers times, and what happens if we just print initial followers each time? What is happening here? I know that anybody who's good at coding is watching this and they're just like, you are such a fucking idiot. And that's okay. Okay. So that didn't do anything. What if we do this? Oh no. Nope, that didn't do it. I need it to, it's not using the number, the next number, right? That's the problem. It does it the first time, that's why this works. But then it's not using the new number, so I need to do that somehow. And how do you do that? Why is it so hard right now? Why is this not coming to me? I'm not asking you, Boots, I'm telling you. Okay. Let's just go through this slowly. So the formula, what we need, the remaining total equals the quantity, and the quantity needs to update, right? Because, yes, so that number will be on day 0, will be the initial followers, right? Fraction lost daily. I just want to make sure I'm thinking of this right. Calculates the final value of a quantity after a certain time has passed. Or wait. Return the remaining, given its initial value and rate of decay. You shouldn't need a loop. Okay, yeah, that's okay. I think I was just realizing that. Or maybe I wasn't. We'll never know. Maybe I'm just faking it. Because the quantity is the initial followers, right? Like it's this. So that's the quantity times the fraction lost daily to the power of days. Right? So if I just do remaining equals, I know I don't need to do this whole thing. I just want to see what happens. I like to print it out, because I just want to make sure I know what I'm looking at. Oh shit. Oh, because I didn't do return. Fine, I'll do return. I know I've added a bunch of extra things that I don't actually need, but no, see, why is that not working though? Something's wrong with my thinking. But why? Dude. Loss versus retention. Wait, what? So wait, that's why it wants this? Is that what it's looking for? No. Damn it. Nightshade, dude. I can't do it. My brain isn't there. It's not working today. I mean, this is pretty standard, actually, but it's not working at all. What am I messing up? What am I messing up? Look at the code snippet. Look at the paragraph under it. The retention rate is the opposite. Oh, do you know what's helpful when you're trying to do things? Is reading. Reading is helpful. Son of a bitch. Okay. Fuck. All right. Well, okay. So let's see if we can do this. Oh, so dumb. That's so dumb. All right. So the retention rate is the opposite of fraction lost daily. So if an influencer lost, then the retention rate would be 80. So I'm so mad. I'm so mad at myself. It's so stupid. Okay, so now how do I do this? Do I do... I mean, I should just be able to do this. But then... So I need the opposite of fraction lost daily. So is it just 100? No, not 100. Because it uses fractions. 1 minus... Is that right? Motherfucker. Excuse my language. I'm sorry. I usually don't curse this much, but I am so mad at that one. Damn it. Thank you, Nightshade Dude. A very good, anybody watching me ever, a very good thing to do if I'm having trouble is just say, hey, why don't you try rereading the instructions? I'm blaming this on ADHD. So that's what I'll do. Because why not? I'm so mad. I'm so glad that we got that, but I'm so bitter. That's what it was. Yeah! We did it. Oh my goodness. Fool. Fool, fool, fool. How many more of these do we have? 2 more? Alright, let's do this. Let's try reading this time. In some cases, data can span several orders of magnitude, making it difficult to visualize on a linear scale. A logarithmic scale can help by compressing the data so that it's easier to understand. For example, at Locked In, we have influencers with follower counts ranging from one... I just can't even focus. I'm just so mad. It was right there. Like, is the opposite of... And I just was like, oh, just plug it in exactly as it is. Why isn't this working? Oh, maybe I'll try for loop. Oh, I don't need a for loop. What am I doing? Okay. We're okay. We're good. We're good. Follower counts ranging from 1 to a billion. If we want to plot the follower count of each influencer on a graph, it would be difficult to see the differences between the smaller follower counts. We can use a logarithmic scale to compress the data so that it's easier to visualize. Write a function, log scale database, that takes a list of positive numbers, data, and a logarithmic base, and returns a new list with the logarithm of each number in the original list using the given base. You may want to use the math.log function. Okay, do I need to call the math? Do I need to import math, or are you doing it automatically for me? Lane, let's find out. This probably won't work, right? Okay, it does not have it. So we will import math. Now, I just want to see, must be real number list. That's fine. I was just checking to see if I needed to import it myself, which I do. Now, let me just make sure how this data is coming through. It's just coming, print data, print base. Are these both lists? Okay, a list and the base is a single number. All right, so since we have a list, we are going to use a for loop this time so that we can do each one. And it wants back a new list with the logarithm of each number in the original list. Okay. So we're going to need to return a list. So this is going to be logs empty list for, we'll just do num in data. We need to do math.log. Oh, and we need to, I know we have to, can we do append? Oh, I don't remember how to do this. Append. No, is it logs.append? Is that it? Logs.append and then math.log of num and base. And then I think that's it. Let me just try. Hey! Hey, go girl! How's Miami? You just caught me at the end, doing some Boot.Dev, crushing it up. You should have witnessed the last one. It was an exercise in learning how to read. And Nightshade Dude saved me. But I got this one pretty quick. I feel pretty good about that one. At least, I think I did. Let's submit it. Booyah! There it is. Hey, I'm actually pretty impressed with that one. Remembering how to append a list? It's been a long time. Nightshade dude saves people? He does save people. Also, I hope it's fine that I said where you are. I mean, you've been posting about it on social, so I assumed it was okay. But hopefully it's a good time. If I shouldn't have said that, I apologize. You missed earlier when I did 14 minutes of streaming and my microphone had died, and I forgot. I didn't notice. And even though Nightshade tried to tell me I was muted, I was not paying attention. So that was fun. That was a good time. And good. Hopefully you're having fun, man. I'm having lots of FOMO, but having a good time. Doing Boot.Dev. And just remembering how bad I am at math all the time, which is always fun. Never listen to that guy? I know, right? He's been helpful. He's been helping me out. He got me. If you can, I don't know if you probably can't see it, but in the chat, he wrote, look at the code snippet and look at the paragraph under it. It's because, here, I'll show you. In this last one, I was sitting here and I kept using, I didn't have this part, the 1 minus, and I just kept using fraction lost daily, and I could not figure out why I wasn't getting the right answer. And he told me to reread the paragraph, and then immediately it's like, oh, the retention rate is the opposite of fraction lost daily. That's why it wasn't working. But then we got there. We figured it out. Okay, I think we only have one more in this lesson. Oh yeah, mean and median. Let's do it. The means and medians are two of the most common ways to summarize a group of numbers. All right, hold on. We're going to pause the music and we're going to listen to Senor
People
Lane.
always talk about below average height or above average intelligence, but that's usually the wrong way to look at it. Now, before I explain that, let's talk about what average even means. It's also called
What does average mean?
And it's
what?
Just the sum of a group of numbers divided by the count of those numbers, how many numbers there are. For example, say I have the numbers 0, 5, 3, and 2. To calculate the average, I add them up, which is 10, and the total count of numbers, how many I have, is 4. So 10 divided by 4 is 2.5. And here's the thing, averages have a problem.
Dang.
In most real-world scenarios, they get massively skewed by outliers. To show you what I mean, let's add a 75 to our example from before. Now, the sum is 85, the count is 5, and 85 divided by 5 is 17. So the mean, or the average, shoots up from 2.5 to 17. But the interesting thing is, there are no numbers in our set that are really close to 17. 4 of them are much lower and 1 of them is much higher. So if you're trying to find a number that represents the typical number in a group, medians tend to be better than means or averages. A median is the middle value after you sort the group into an ordered list. It ignores how big the other numbers are and just picks the one in the center. So using our same example, first we sort the list and then we just take the middle number. In this case is 3. So the median is 3. And if you have an even count of numbers, you just average the 2 middle ones. For example, if the numbers are 0, 2, 3, and 5, we just take the mean of 2 and 3, which is 2.5, and that's the median. Now, medians are a bit more annoying to calculate because you have to actually sort the list instead of just doing some simple arithmetic, but it is usually...
Do you think this is foreshadowing the next part of the lesson of when we start doing, like, I'm assuming we're going to do some, like, big O notation and all that fun stuff? I don't even know what that means. I've just heard it before. I just know that it's a term that people use. I sort of know. I've read it enough times to know a little bit. Just a little bit. We're going to learn. We're learning. Oh, I stopped him right near the end.
When you're looking for a representative number.
Okay. The mean or average of a group of numbers is the sum divided by the count of those numbers. That one I did know. I remember that from being a young buck in school. For example, say we have the numbers 2, 5, 1, 6, 75. 17.8 is it. Yes, the mean is 17.8. The median is 5. Okay, we don't need to read that. Which is usually best? It feels like everyone always talks about averages, so you might think that the mean is the more useful representative value from a group of numbers. The problem is, as you can see above, a big outlier like 75 skews the mean, while the median is less affected by it. As a rule of thumb, the median is often a more accurate representative number of a group, especially if there are outliers in the data. It can just be a bit more work to calculate because it involves sorting instead of simple arithmetic. All right, assignment. Nightshade. He's drunk with power, Code Girl. We now need a way to show our locked-in influencers the average mean follower count of the people they follow. This will help them know if they're following people who are more or less popular than them. Story of my life. Nice. Complete the average followers function. It should return the average of the given list of numbers. If the list is empty, it should return none. Okay. So he wants us to return the average, the mean, not the median. So hopefully this shouldn't be too ridiculous. So let's just see what we get in this list, because I don't like to read. Nums. Okay, it's a list of numbers. Perfect. Be right back. Gotta make a phone call. No worries. Have fun. Hopefully it's a fun call. Okay, this should be super straightforward. This should just be, we need to add up, so we need a for loop, and we need to add everything up, and then we need to divide it by the length of nums. So for num in nums, we do, I guess we need a sum equals 0, sum plus equal num. And then when that's done, we need to return the sum divided by length of nums, right? Oh, I failed one. Oh, divide by 0, of course. So what's the easiest way to do that? None. Oh, so it's just an if statement, right? I was hoping to get away with no ifs. So we can just do if nums, or length of nums is 0, then return none. That's it, right? I wish you guys some nuns. Nice. I wish you would all believe me when I tell you that, like, if I was doing this without streaming and I was sitting here by myself and I got it right, everything that you're witnessing is exactly how I would be acting. Some is a built-in Oh, I thought you were just making a joke about nuns. I didn't realize you were trying to tell me a Python thing. So wait, because instead of doing this, could you just do, wait, based on what you're saying, could you just do this? Could it be that short? Oh, yeah, that's way faster. I forgot sum was a function. But, whatever. I wonder if that's what the solution is. Let's find out. Did he write that as the solution? Oh, no. Lane did it the long way. Because he's a good guy like that. Yeah, that's sweet, though. That's way faster. What a much shorter way to do it. Hey, we beat Chapter 2. We finished it. We did it together, folks. How great. Oh, man, it's getting late. I didn't realize that. I wonder what time my kids are coming home. The truth is, I have no idea. They're gonna come home at some point, but I don't know when. All right. Well, that's all I wanted. Oh, Big O! I told you. I knew it. I hadn't even looked at that, and I told you that's why we were learning that right now, because we were gonna do Big O notation, and I'm actually very excited to learn about this because I have always like peripherally paid attention to it, but never really got like dug into it, and I'm actually really excited. I am excited to learn about it. I'm not gonna do it right now though, because I don't know. I think my kids are probably coming home in the next like half hour. Oh, actually, maybe right now. I'm just getting. Hold on. Time to check. Make Kayla come home and get 2 cars. Okay. Hold up. Of course. Yep. Yes, you can. Yes, you can. I'll come let him in. Okay. I'll be right back. I gotta go let my son come and get something to play with at his grandma's house. Uno momento. We will. Heck yeah. All right. I've now officially got my time, and I don't have that much more time. But this has been awesome. I think I'm just going to end it now because I've been having fun, and the only other thing I can think to do right now is play tape to tape. And I don't know if anybody wants to see that. But I got to take a break from Boot.Dev. I don't think I can handle getting back into something new right at this moment. What's this? Oh, yeah, that's my Python thing. This is awesome. Nightshade dude, first off, awesome having you. Code Girl, amazing. I'm gonna edit that video and put it up, and it's gonna be awesome. I can't wait to turn it into a black and white video. It's gonna be great. And yeah, we're gonna keep doing this. We're on 4 days in a row now of trying to do it at 3 o'clock, usually 3 to 5 Eastern. but today was a little bit later, but we still did it. And so that's the goal. Every day, every day, every day, every day. Consistency, baby. Okay, I'm going to get out of here, and I'm going to let everyone else out of here. I would raid people, but I don't think I really have anyone in here. Unless Nightshade Dude, do you want to raid somebody? I think it's just you. We could. I don't even think anybody I know is on right now. Oh, is Loki on? Oh, okay, well if Loki's in, we could raid Loki. That'd be cool. Even if it's just me. All right, let's raid Loki. Dude, thank you so much, and thank you for helping me solve that problem by reading. It was awesome. All right, we'll hang out with Loki for a little bit. I'm gonna raid Loki. All right. This is so much fun. Okay. What is he doing? Oh my gosh, just wait till you see this. All right. Peace out, everyone. We are doing the raid. Bye, everybody. Thanks.